How's it going, everyone? This is an example of how to solve a question that asks for probabilities based on a normal distribution. So, a study on average hours of sleep per night showed a normal distribution with a mean value of 7.3 and a standard deviation of 0.4. So that's good to write down right away. So we have a mean value of 7.3 and a standard deviation of 0.4. And then we're asked to find some probabilities. So part A, find the probability that someone gets less than 7 hours of sleep. Now it's always helpful to draw a normal distribution for these kinds of questions. So in the middle we have 7.3 as our mean value, and somewhere less than that we have 7, and we're looking for this shaded region right here. The area under the curve of the normal distribution is the probability of being within that range of values. So we want the probability of x being less than 7. The first step is always convert to the z scale. So our z value is going to be x minus mu divided by sigma, which in our case is 7 minus 7.3 divided by 0.4. So that is going to be negative 0.3 divided by 0.4, and that gives us negative 0.75. So on the x scale, that's a 7 and a 7.3. On the z scale, that's a negative 0.75 and a 0 in the middle, since the standard normal distribution has a mean value of 0. So step 2 is we find that z value on the z table, negative 0.75. So there's the z table, negative 0.7 is right here. The second decimal point is a 5, which takes us to this column right here. So we match up that row and that column, and it shows us the probability of being below that value if you have a normally distributed random variable with a mean of 0 and a standard deviation of 1. So that's 0.2266. 0.2266. So the probability of a z value being less than negative 0.75, which is the same as the probability of x being less than 7 in our case, is 0.2266, or in percent form, 22.66%. And that's part A. Now, on to part B. Find the probability that someone gets more than 8 hours of sleep. So again, we'll start by drawing the picture. There's our normal distribution. Mean value of 7. Somewhere above that is an 8. And we want this shaded region right here. Right, we want the probability of x being greater than 8. So again, step 1, convert to the z scale. Z is x minus mu divided by sigma. 8 minus, and if you recall, our mean value is 7.3, and our standard deviation is 0.4. So 7.3 divided by 0.4. So that's going to be 0.7 divided by 0.4, which is going to be 1.75. So on the Z scale, that is a 1.75. And we want to find the probability of being above that. Now the Z table only shows us the probability of being below it, but it's still our first step to find that. So the probability that Z is below 1.75, we look for 1.75 on the Z table. There's 1.7 right here. We match that up with the second decimal point, which is a 5. So that's the column there. And we have 0.9599. 0.9599. 0.9599. That's this not shaded area here. That's not what we're looking for. We want the shaded region. Well, that's going to be the total minus the not shaded region. So the probability that Z is greater than 1.75, which is the same as the probability that X is greater than 8, well, that's going to be 1 minus 0.9599, which is going to be 0.0401. Or in percent form, that is going to be 4.01%. And that's our answer. Now, on to part C. So part C asks, find the probability that someone gets between 7 and 8 hours of sleep. Again, we'll start by drawing the picture. There's our normal distribution. There's a 7 in the middle. There's, 7.3 in the middle. That, by the way, should also be a 7.3 because that's the mean value. In part B. That's why we plugged in 7.3 right there. So that's a 7 somewhere below that. That's an 8 somewhere above that. And we're actually looking for this shaded region right here. That's what we're looking for. So we want the probability that X is between 7 and 8. Now, we have two Z values. Z1, which will be X1 minus mu divided by sigma, which is 7 minus 7.3 divided by 0.4, or negative 0.3 divided by 0.4, and we actually calculated this before in part A, and we came to negative 0.75. Negative 0.75. Then we have Z2, which is X2 minus mu divided by sigma, which is 8 minus 7.3 divided by 0.4. And that gave us 0.7 divided by 0.4, and we actually calculated this in part B above, and that was 1.75. 1.75. So, if we look for the probability that Z is less than negative 0.75, well, that's what we found in part A. That's what we found right here. That's the 0.2266. 0.2266. And that's actually this red region right here. If we look up Z2 on the Z table, we get the probability that Z is less than positive 1.75. Now we actually looked that up as well. That was this value right here that we looked up in part B, 0.9599. And that's this outlined region here. So we want the black shaded region. We want that area. What we have is the yellow outlined region and the red shaded region. How can we get the black shaded region if we know those two? Well, we take the yellow outlined region and subtract the red shaded region, which effectively cuts it off, and what we're left with is the black shaded region. Right? So we just take the bigger number and subtract the smaller number. And the numbers I'm talking about are the probabilities. So the probability that Z is between negative 0.75 and 1.75, that's going to be 0.9599 minus 0.2266. And that gives us 0.7333, or 73.33%. And that's the answer. Okay, that's also equal to the probability that X is between 7 and 8. Because on the Z scale, that 7 is a negative 0.75, and that 8 is a positive 1.75. And that's how we do part C. And now we're just left with part D. Part D asks, what is the hours of sleep value that separates the top 10% of people that sleep the most? Okay, separates the 10% of people that sleep the most from the rest of the group. So here we're actually given the probability or the proportion, and we're asked to find the hours of sleep value. Okay, so rather than knowing the X value, converting to Z, and finding the corresponding probability, we're given the probability value, we find the corresponding Z value, and then convert to X. And like always, we'll still start by actually drawing the picture. So there's our normal distribution. There's 7.3 in the middle on the X scale, which on the Z scale is a 0. So somewhere here is that top 10% who sleep the most. And we want to know what that cutoff is on the X scale. We know this is 10% or 0.1. We want to find out what's that Z value, what's that X value. Well, to match up a Z value with a probability, we need the probability of being below a certain value. So if this shaded region is the top 10%, well then the not shaded region is going to be the bottom 90%, 0.9000. So we're going to look for that probability on the Z table and find the corresponding Z value. So we're going to look for whatever probability is closest to 0.9000. So we look around and we see this value right here eventually, 0.8997. That's the value on the Z table, the probability value closest to 0.9000. And we find what Z value does that correspond to? Well, up to the first decimal point, it's 1.2. And then the second decimal point is an 8. So it corresponds to 1.28. That's our Z value, 1.28. 1.28. And then we want to know, okay, how do we get the X value from that? Well, Z equals X minus mu divided by sigma, and if you rearrange that formula to solve for X, you're going to get X equals mu plus Z sigma. Okay, if you multiply both sides by sigma and then add mu to both sides, that's what you will get. So in our case, mu is 7.3, Z is 1.28, and sigma is 0.4. So we just calculate that. 7.3 plus 1.28 times 0.4 gives us 7.3 plus 0.512, which then gives us 7.812. Or, if we want to round to one decimal place, that's just a 7.8. So, the top 10% of sleepers, the people top 10% who sleep more than the remaining 90%, they get 7.8 hours of sleep or more per night on average. So that's part D. And that is all the parts of this normal distribution question. So I hope that helps, and until next time.